Rockwell Collins' new ThreatTrack software enables 6 new weather analysis tools that assist flight crews in assessing actual thunderstorm threats. Note that on the Multiscan ThreatTrack control panel, the TURB function has been removed and replaced with a Weather plus Threat plus Hazard selection. When Weather plus Threat plus Hazard is selected, Multiscan's ThreatTrack features are added to the essential automatic multiscan capabilities previously described in Modules 1 and 2. ThreatTrack is based on Rockwell Collins' Track While Scan technology, which is described in detail in Module 4. Track While Scan enables the following new features: Core Threat Analysis, Predictive Overflight, 2-level enhanced turbulence, mid-altitude associated threat, mature cell associated threat, and anvil top associated threat. A key design goal for ThreatTrack is to make the colors displayed on the ND more representative of the actual thunderstorm threat. When the Track While Scan technology determines that the convective activity is more intense than the precipitation level would normally indicate, Core Threat Analysis increases the color level to more accurately represent the actual threat. When compared with this ground-based radar threat image, it can be seen that Core Threat Analysis enables a better representation of the actual cell threat. In cases where the convective activity is already properly displayed, colors are left unchanged. Thunderstorms can grow as rapidly as 6,000 feet per minute. These rapidly growing cells push a turbulence bubble above them as they grow that can produce severe turbulence even though the aircraft is several thousand feet above the visible top. Predictive Overflight uses ThreatTrack's Track While Scan technology to detect and measure cell growth rate, and then predicts the resulting bow wave turbulence created by the storm. The cell may eventually appear on the display as it continues to grow toward the aircraft altitude. The Predictive Overflight icon is used to warn flight crews of the potential turbulence threat from a cell that is growing towards the aircraft's flight level. Note that this Predictive Overflight icon appears in the black, indicating a cell that is growing towards the aircraft's altitude. 2-level enhanced turbulence measures severe and ride quality turbulence out to 40 nautical miles. When the new FAA standards for severe turbulence are met, solid magenta is displayed. When the radar detects less severe ride quality turbulence, consisting of light to moderate chop, then speckled magenta is displayed. Multiscan ThreatTrack's associated threat feature analyzes individual thunderstorms and infers the additional threat associated with the cell based on its intensity and life cycle development stage. During the early developing cumulus stage and late dissipating stages of the cell, threats are relatively minor. However, during the later stages of cumulus development, cells do become electrified around the freezing level due to the collisions between positively and negatively charged ice particles. The resulting electrical potential forms the basis for possible lightning discharges. During the mature stage of a thunderstorm, hail and turbulence may extend outside the cell boundaries, and severe cloud-to-cloud and cloud-to-ground lightning is possible. In addition, at cruise levels, hail may be thrown out of the top or sides of the cell and in the downwind direction. ThreatTrack's associated threat feature provides flight crews with a mid-altitude associated threat, a mature cell associated threat, and an anvil top associated threat that correspond to each of these 3 scenarios. The following is an overview of the 3 associated threat warnings. First, let's look at the mid-altitude associated threat warning. Toward the end of the cumulus stage of thunderstorm development, cells become electrified but do not yet have extensive high-altitude convective activity. Nevertheless, these mid-altitude cells do contain lightning potential. Multiscan ThreatTrack radar denotes this mid-altitude lightning threat by placing red speckles within the cell boundaries. This mid-altitude associated threat warning is displayed until the aircraft climbs higher than 10,000 feet above the freezing level. Second, during the mature stage of thunderstorm development, strong updrafts carry moisture aloft, with the result that there is high reflectivity at cold temperatures. These mature cells create lightning and hail potential and produce very strong turbulence. What's more, because the strong updrafts associated with these thunderstorms can exit the top or sides of the cell, the potential danger area for hail and turbulence can extend well outside the cell boundaries. In the case of a mature cell-associated threat warning, multi-scan ThreatTrack extends the warning area outside the cell boundary to denote the increased threat from the mature cell. The associated threat icon for mature cells is displayed at all altitudes. Finally, above 25,000 feet, multi-scan ThreatTrack displays an anvil-top associated threat. The radar uses cruise-level winds to extend the threat region downwind of the cell. An example of this will be shown shortly. Note the more benign non-electrified cell directly in front of the aircraft. In this case, no associated threat icon is displayed. As explained earlier, mid-altitude associated threat consists of red speckles contained within the cell boundaries. These cells are potential lightning sources. Approximately 80% of lightning strikes occur within 3,500 feet of the freezing level. When electrified cells are present, and when it is practical, transit through the area near the freezing level as quickly as possible. Also, maintain an appropriate distance from electrified cells in accordance with company guidelines. Remember that the mid-altitude associated threat icon will no longer be displayed once the aircraft climbs more than 10,000 feet above the freezing level. In this example, the aircraft is descending from cruise altitude and is more than 10,000 feet above the freezing level. Thus, the icon is not displayed. However, note that as the aircraft descends below the activation altitude, the speckles within the cell boundary are displayed. 10,000 feet above the freezing level was the threshold chosen to activate the mid-altitude associated threat in order to give flight crews time to determine the best route of flight through electrified regions prior to reaching the vicinity of the freezing level. Remember that in the case of a mature cell-associated threat warning, turbulence and hail may extend well outside the cell boundary. Hail can be lofted out the top or sides of the cell, and shear effects may create significant turbulence as well. Therefore, multi-scan ThreatTrack extends the warning area outside the cell boundary to denote the increased threat of a mature cell. Note that the speckled region is not a threat boundary. In some cases, flight crews may penetrate this region without incident. Turbulence and hail might be present, but at a different altitude. Conversely, on occasion, turbulence and hail can extend outside the icon boundaries. The mature cell-associated threat icon is displayed at all altitudes during all phases of flight. There will be occasions where the associated threat icon appears suddenly. Notice this cell and the mature cell icon that appears as the aircraft approaches it. Remember that the total life cycle of a cell is about an hour. And for rapidly growing cells, the transition from the cumulus stage to the mature stage can happen in a matter of minutes. When the cell reaches the mature cell threshold, the icon is displayed. Mature cells often form an anvil top downwind of the thunderstorm. In these instances, hail can be ejected from the top of the cell and create a hail danger region downwind of the cell. At cruise altitude, multi-scan ThreatTrack's anvil top associated threat warning uses the upper level winds to define a potential region of ejected hail downwind of the cell. The region will be larger or smaller depending on the wind velocity. This is another reminder that, whenever possible, it is best to transit thunderstorms to the upwind side. The downwind threat region is activated when the aircraft climbs above 25,000 feet. Notice here that below 25,000 feet, the mature cell-associated threat icon is centered on the cell. Climbing through 25,000 feet, the icon shifts direction to orient along the upper level wind axis and increases the downwind length in direct proportion to the wind velocity. It is important to understand that all associated threat warnings are inferred threats based on the nature of the thunderstorm that the radar has evaluated. In other words, the red speckles do not indicate a directly detected threat. The radar cannot actually see hail and turbulence in the red speckled regions. Thus, directly detected weather always takes priority over the red speckled associated threat icon. For instance, in this scenario, if it is necessary to transit this region, then the preferred route of flight takes the aircraft through the red speckled area. The flight crew would not turn left into the weather that is painting yellow to avoid the red speckled area in front of the aircraft, even though the yellow cells do not appear to be electrified. The red speckled associated threat icon is designed to give flight crews a more complete weather picture and enable them to make better avoidance decisions. Whenever possible, speckled areas should be avoided. Here's a second example of directly detected weather taking priority over the associated threat icon. In this scenario, if it is necessary to transit this region, pilots should maintain proper distance from the directly detected red cell core, even though the green region contains the inferred threat represented by the associated threat icon. Thus, for this situation, this path represents the safest and most fuel-efficient flight path. However, remember, speckled regions do represent significant hail and lightning potential. Therefore, whenever possible, these regions should be avoided. To illustrate, note that right as the aircraft arrives at the edge of this mature cell associated threat icon, the radar indicates fail and ground clutter flashes on and off the display. This occurred due to the fact that the aircraft was struck by lightning and once again emphasizes the need to avoid the speckled regions when practicable. In summary, remember these key aspects of the Rockwell-Collins Multi-Scan ThreatTrack radar. Core threat analysis more closely relates the color of the cell on the ND to the actual thunderstorm threat. Predictive overflight measures a cell's growth rate and then predicts the turbulence bow wave above the growing storm. When turbulence is predicted based on the rapidly growing cell beneath the aircraft, a predictive overflight icon is displayed. Because predictive overflight is based on a measured thunderstorm growth rate, pilots should avoid the region overlaid by the icon. Two-level enhanced turbulence paints severe turbulence as solid magenta and ride quality turbulence as speckled magenta. The red speckled associated threat icon is displayed in three different ways. Mid-altitude electrified cells have red speckles contained within the cell boundaries. For mature thunderstorms, the red speckles are extended outside the cell to show the potential for turbulence and hail outside the cell boundaries. And finally, above 25,000 feet, upper-level winds are used to predict the anvil top. So this icon will turn and align with the wind direction and extend downwind based on the wind velocity. It is important to remember that Multi-Scan ThreatTrack's associated threat is an inferred threat. Therefore, painted weather should always take priority for avoidance decision-making. The mid-altitude associated threat warning is displayed when the aircraft is less than 10,000 feet above the freezing level, and the anvil top associated threat region is extended downwind of the cell above 25,000 feet. The mature thunderstorm associated threat is displayed at all altitudes in all phases of flight. Note that when an aircraft commences its descent, the ThreatTrack software automatically scans down along the aircraft descent flight path, so it is no longer necessary to momentarily go to manual at top of descent, as in previous versions of the Multi-Scan software. Rockwell-Collins recommends that the radar be operated in auto, cal gain, and weather plus threat plus hazard in all phases of flight in order to take advantage of the Multi-Scan ThreatTrack safety features.